Hi everyone, this is video 1 for your AP Calc summer assignment. This video should be a relatively short one, and for those of you who are just coming out of pre-calculus, it should look sort of familiar, especially if you had me for honors pre-calc this year. So today we're going to talk about the definition of a limit and the limit process. If we look at an example, we have a soccer game. So in this soccer game, you're watching it on TV, and all of a sudden, your computer buffers, or you're watching it on the computer, and all of a sudden your computer buffers. Can you figure out what happened when it comes back on? That's what a limit is. A limit is not what actually happens in a location. It's what you expect to have happen based off of the before and after. So in this problem, the soccer player is kicking the soccer ball towards the goalie. So you can see right there, he's kicking it towards the goalie. He gets really close to the goalie. Then we don't really know what happens for a little bit. And then all of a sudden, there's the goalie. So we can see the soccer ball is past him, and it's in the goal in this one. So can we kind of guess what happened in that buffering one? Yes, we kind of know that, he got past the goalie somehow. We don't know exactly what happened in that moment in time, but we have a really good estimate. That's the limit. That's what a limit is. So let's look at some examples. Well, to find a limit, graphically and numerically, we need to know three things. So the limit from the right must exist, the limit from the left must exist, and the limit from the right must equal the limit from the left. And if those three things are not true, then there's no limit. This is very important. Definition part 3 is how we prove that a limit exists. So you have to show that the limit from the right equals the limit from the left in order to show that a limit exists. So if we look at this problem, this is just a simple line. And the line's x plus 2, and it's already graphed for us. And we want to know the limit as x approaches 3. So in order to show that the limit exists, we have to show that the limit from the left exists. So we write that as the limit as x comes towards 3 from the negative direction of x plus 2. So as x comes towards 3, we can see here's 3, and based off the equation, we know that 3 plus 2 is 5. So as x comes in the negative direction, what are we getting close to? So then from the negative direction, we're getting close to 5. So that's part 1. Then part 2 says, well, what about when it comes from the positive direction? So the limit as x approaches 3 from the positive direction. Well, if we come from the positive direction, well, that line's still getting closer to 5. So we know the left-hand limit is 5, and we know the right-hand limit is 5. So therefore, we say that the limit as x approaches 3 is 5. But in order for that to exist, these two have to be the same. So since they are the same, we know our limit is at 5. Let's look at our next example. In our next example, we have this empty spot. We call this a removable discontinuity because if we factor this, the x minus 3's are removed, and therefore it's a removable discontinuity. But anyway, that was bonus information. So let's evaluate the limit as x approaches 3. So the limit as x approaches 3 from the negative side of this function. By the way, this is the function they gave us, not what I just simplified. So we have to write this long thing because that's what we're looking at. So as we come to 3 from the negative side, the y value is getting closer to 5. So we know the limit from the left-hand side is 5. It doesn't matter that we can't plug 3 in here. It doesn't matter that that makes it 0. We don't care about that. We just want to know what it looks like is happening. And as we get closer and closer to 3, this graph, the y value is getting closer and closer to 5. So likewise, if we do the limit as x approaches 3 from the positive side of this function, so what happens as it gets closer and closer to 3 from the positive side? So our y is getting closer and closer to 5. And because the left-hand side, we can see the left-hand side's with the negative, remember, and the right-hand side are the same, because they're equal, we know that the limit as x approaches 3 of this function is 5. All right, so let's look at this one. So this one's a piecewise function. See how there's two pieces? Hopefully you could graph something like this if you needed to. So this one wants to know the limit as x approaches 2. So as x approaches 2, so we have to check the left-hand side, remember, of this function. So as we do the left-hand side, what does our graph, as we get closer and closer to 2, what does it look like it's getting close to? Looks like it's getting close to 4. We don't care that there's that spot down here. We don't see this spot. The limit's just what is it getting close to as we come from the left-hand side. And as we come from the left-hand side, the y value is getting close to 4. Likewise, as we come from the right-hand side, what's it getting close to? Well, it's getting close to 4 also. So we know the limit as x approaches 2 is 4. And we have shown that because the limit on the left is 4 and the limit on the right is 4. In order for the limit to exist, they must be the same. So now let's look at this one. So now we have this piecewise function, and we want to know the limit as x approaches negative 2. So this is saying the limit as, we have to show the limit from the left and the right, remember? So the limit from the left of this function. So what's happening as, what's the y value as it's coming towards, from the left-hand side towards negative 2? Well, the y value is negative 1. And then we have to look at the right-hand side. What's the limit of the, as the right-hand side goes towards negative 2? So if we're going towards negative 2 from the right-hand side, that's also, no, it's not negative 1. Bad. What's happening as we come from the right-hand side? The y value is positive 1 this time. Uh-oh. So on the left-hand side, it's negative 1, and on the right-hand side, it's positive 1. They're not the same. So since they're not the same, the limit as x approaches negative 2 does not exist. Because remember, the definition of a limit says that in order for it to exist, the limit on the left and the right-hand side has to be the same. So let's look at this one. We have to be able to draw a graph of this in order to evaluate the limit as x approaches 2 of this function. So if you want, pause me, try to draw a graph of this, but I'm going to go ahead and continue. The first piece says that y, remember this is y equals 1 when x does not equal 2. So think about that for a second. If x is 3, y is 1. If x is 1, y is 1. If x is 0, y is 1. So if we imagine that, we have 3, 1, 1, 1, 0, 1, any place that x does not equal 2. So every place but that one little spot where it equals 2, that graph is 1. The y value is 1. Then it says when x is 2, That one spot where x equals 2, the y value is 0. So there's our y value. That one spot where x is 2, y is 0. Every other place in all of the domain, the y value is 1. But that one spot, the y value is 0. All right, so now it wants us to evaluate the limit as x approaches 2. So we have to check our left-hand side. And by the way, yes, you have to write this out to prove that the limit does or does not exist every single time. I know it's a pain, but the AP graders are a pain too. So if we look at 2 from the negative side, the y value is 1. That's what we would think, that's what it's approaching. We don't care about that spot down here, remember. The limit is what we expect to have happen, and the y value is getting closer and closer to 1. If we look at it from the positive side, well, from the positive side, the same thing's happening. The y value is still 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and all of a sudden we would expect it to be 1. So we can say, since the left-hand side is 1 and the right-hand side is 1, we can say the limit as x approaches 2 of this function is 1. Remember, that's not what actually happens at 1. I'm sorry, that's not what actually happens at 2. At 2, the value is 0. So the limit as x approaches 2 is 1, but the value at 2 is 0. These two statements are not interchangeable. You cannot switch them. They do not mean the same thing. So the limit is what it looks like is happening, and the f of 2 is what actually happens. They're two different answers on some problems. So just be very careful and make sure you understand the definition of a limit. So if we look at this one, in pre-calc, you may have said that the limit when it goes to infinity does not exist. In this class, we're going to say either negative infinity or positive infinity. So here, if we look at this, the limit as x approaches negative 1 in the negative direction. So if we come to negative 1 in the negative direction, our graph's going down infinitely, so we say that's negative infinity. If our graph is going in the positive direction towards negative 1, it's going in the positive direction towards negative 1. That one's going up forever, so we say that one is positive infinity. Well, negative infinity and positive infinity are not the same thing. So negative infinity and positive infinity are not equal. So the limit, the left-hand limit, is not the same as the right-hand limit. So we would say that the limit as x approaches negative 1 of this function does not exist. D and E does not exist because the left and right hand side are two different values. Now, if both were going to positive infinity, we would say the limit's positive infinity. Both are going to negative infinity, we would say the limit's negative infinity. But because one's going to negative infinity and one's going to positive infinity, the limit does not exist. All right. So now we look at this crazy function. And this crazy function's one of the few that does not exist. This thing, we say that it oscillates back between y values, so it's like jumping from 1 to negative 1, from 1 to negative 1, from 1 to negative 1. It just jumps back and forth so quickly, these lines aren't even really here, but the calculator has no way of graphing it without connecting the dots. So anytime you see this one, we say that this limit does not exist because it's jumping back and forth so quickly that that limit does not exist. So there's three ways that we see a lot where we say the limit does not exist. The first big one that uses our definition, it approaches different numbers from the left and right, from the right and left. We also say it does not exist if it increases or decreases without bound. But more specifically, this limit goes to infinity or negative infinity. So there's technically no limit, but we don't just write does not exist. We specify, oh, it doesn't exist, but it's going to infinity or negative infinity. And then just like in that last example, if it oscillates between fixed values, if it jumps up and down, well, that's another example of when the limit does not exist. So there's three major times when the limit does not exist. So let's look at this definition again. This says the function f has a limit at 2 as x approaches 1, even though f is not defined at 1. So here, you can have a limit even though there's that open hole there. So because the left is going towards 2 and the right is going towards 2, the limit equals 2. So we don't care that there's that hole. That hole means nothing to the limit. Likewise, we could write this same exact thing over here. There's a hole, and it doesn't matter that there's a closed spot. So the second bullet says the function g has limit 2 as x approaches 1, even though the value does not equal the limit. So even though the limit is that, and the value at 1 is 1, so even though the limit is 2 and the value is 1, we still say that there is a limit of 2. They're two different things, remember? So the limit as x approaches 1 is 2. And likewise, this one does have a value that's equal, and its limit is still 2. So it is possible that the limit of the value could be 2, and the actual point could be at 2. So it's possible that that's closed in. All right. So one of the things that you need to know how to do is evaluate from the left and right hand side. So this example, I'll pull the graph up so we can see it. So the example, x approaches 0 from the positive side. So that means we're coming towards 0 from the right-hand side. So let's assume that graph looks like that. It's kind of hard to see. So if we come to 0 from the right-hand side, the y value is getting closer to 0. If we're going to 2 from the positive side, now this one doesn't really have a value. It looks like it stops at, let's assume that graph looks like that. Do we see any value at 2 from the positive side? See, there's like that empty gap here. There's nothing coming at 2, so there's nothing going on there. So this graph stops at 3, so it doesn't look like it has a value at 2. So one of the definitions of a limit is it has to exist from both sides. So this one, since there's no positive value, does not exist. But if we come to 2 from the negative side, going towards 2 from the negative side gets closer and closer to 4. There's an open circle there, but remember the open circles really don't matter much. So then if we look at part D wants to know the overall limit as x approaches 2. So to remember to do that, we have to look at the left-hand side, which we already know is 4. We have to look at the, that would have been the left-hand side. The left-hand side is 4, and we know the right-hand side does not exist. And our question is, are these equal? Is 4 equal to does not exist? And the answer is no. So this limit must also not exist, because the left and right-hand side has to exist in order for the limit to exist. And then last but not least, part E says, what's the limit as x approaches 3 from the positive side? So if we come to 3 from the positive side, the y value is getting closer and closer to 0. So I want you to take a few seconds. I want you to pause me. I want you to try these true-false questions that you should have on your paper in front of you, and then I will give you the answer. So go ahead and try these true-false questions that you should have on your paper, and then I will give you the answers. So pause me for a few minutes, give it a try, and then check your answers. All right, so here are your answers. Letter A should be true. Letter B should be true. C should be false. D should be true. E should be true. F should be true. G should be false. H should be false. I should be false. And J should be false. If you do not understand any of these problems, you need to look back and look at the definitions of a limit again. So I'm not going to go through and explain these, but do check your understanding, and hopefully you understood all of those. So there are several ways of evaluating a limit. One of the ways we can evaluate our limit is with a table. So I'm going to pause. Alright, so I'm going to type in my calculator this function, and if you have a TI-84, get in the habit of using alpha y equals to create your fractions, and then you just use x cubed minus 1 over x minus 1. If you have a TI-83, you're going to need to use parentheses to type that in, and I typed that in wrong, so let me fix that real quick. So x cubed, delete, minus 1. There we go. So that looks right now. And then the other thing is you need to know how to change your table so it counts by something other than 1. So to do that, you're going to go to second window and then change this from auto to ask. And this is an awesome feature. So what we can do is we can check as we get closer to 1 from the negative direction or from the left-hand side, and as we get closer to 1 from the right-hand side. And if those numbers are the same, then we know what our limit should theoretically be. So let's try. 0.75 is kind of far away from the limit as x approaches 1. So 0.75 is kind of far away on the left-hand side. So we're going to go to second table, and we're going to type in 0.75. We know the y value there is 2.3125. Then we're going to type in 0.9, and then 0.99, and then 0.999. So if we type in 1 doesn't work. 1 has an error because 1 minus 1 is 0, and 0 cannot be on the bottom. So 1 doesn't exist. All right, but let's look back. If we look on that, if we look on that left-hand side, what's happening? So 0.75 is getting 2.3125, and then 2.71, and then 2.9701, and 2.997. See, it looks to me like as we get our x value gets closer to 1, our y value is getting closer to 3 maybe? But remember, that's just the left-hand side, so we need to check the right-hand side. So now I use my table and I type in some of the numbers that are on the right-hand side of 1. So 1.001, 1.010, 1.1, and 1.25. And I kind of messed this up. I should have typed, yep, let's try that again. So I'm going to go back up to the top, and I'm going to do it differently this time. So I'm actually going to start with 1.25 because that's farther away from 1, and then 1.1 because that's getting closer to 1, and then 1.01 because that's even closer, then 1.001. So if we look at it now from that way, we know starting kind of far away, we have 3.8125, then 3.31, then 3.03, and then 3.003. And by the way, in AP Calc, we're going to round to 2 decimal places. So, sorry, did I say 3 decimal places at least, 4 when possible, 4 is better, but the AP people require 3. So make sure you're always rounding to 3 decimal places. So if we look, it starts at 3.8 and then 3.3, and as x gets closer to 1, as our x value gets closer to 1, our y value is getting closer to 3. So we know our limit as x approaches 1 from the left-hand side was 3. And our limit as x approaches 1 from the right-hand side was 3 also. Whoops, sorry. Was 3 also. So therefore, since the left-hand side's 3 and the right-hand side's 3, we know our limit is 3. So I gave you one to try. Go ahead and take a minute. Check this table out. We're looking at the limit as x approaches -2. So we have to check as it gets closer to -2 from the left-hand side, then as it gets closer to -2 from the right-hand side. So go ahead, pause me, fill this table in. I'm going to leave you here. Alright, so I've just filled in the table using my calculator, and if we look, as this goes towards -2 from the negative side, so as the limit of x approaches -2 from the negative side of this function, we know the limit, it looks like it's getting closer and closer to 4. Remember, it doesn't matter that this does not exist. That would be an open circle when you graph it. It just doesn't exist because you cannot put -2 into the bottom because that makes the bottom 0. So you have to use a different method to analyze this limit. Likewise, if you do the limit as x approaches -2 from the positive side of this function, it's still, as we get closer and closer to -2 from the positive side, the y values are still getting closer and closer to -4. Oh, yep, this was -4 over here too. So since the left-hand side's getting closer to -4 and the right-hand side's getting closer to -4, the limit as x approaches -2 must be -4. All right, so that is the end of this first lesson. When we come back, we'll do other ways of analyzing a limit, including factoring and rationalizing. So this is the end of lesson 1.